Okay, let's dive into this. Today, we're tackling a classic coding challenge called Bomb Enemy. It's a really fun puzzle that seems simple at first, but it's hiding a super elegant and efficient solution right under the surface.
So, imagine you've got this grid. Your mission, should you choose to accept it, is to find the single best empty spot to place a bomb to cause the absolute maximum amount of damage.
First things first, we need to understand the rules of engagement on this battlefield. Like any good puzzle, it's the constraints that really make it interesting.
Okay, so the grid is made up of three things: enemies, walls, and empty spaces. That's where we can drop our one and only bomb. Now, this bomb is powerful. It sends a blast wave up, down, left, and right. But, and this is a big but, it's not all powerful. Walls will stop the blast in its tracks, which creates these little tactical corridors we have to think about.
So, what's the most straightforward way to solve this? I mean, what's the first thing that pops into your head? It's probably what we call the brute force approach. The logic is pretty simple, right? We'd go to every single empty spot on the grid, and for each one, we'd scan out in all four directions, counting up enemies until we hit a wall or just fall off the edge of the grid. Then, we'd jot down that number, move to the next empty spot, and do it all over again.
And yeah, that works. It'll get you the right answer eventually. But can you just feel how inefficient that is? For a big grid, we'd be doing a ton of repeated work, scanning the same rows and columns over and over and over again. It's a huge waste of time. We can definitely do better.
So here's the game changer. Instead of recalculating everything from scratch for every single spot, let's do all the hard work up front. Let's pre-calculate the damage potential for the entire grid all at once. We're making a fundamental shift in our strategy here. We're moving away from that slow, repetitive, recalculate everything process to something fast, efficient, and way, way smarter.
To pull this off, we're going to create a second grid. Think of it like a cheat sheet. Let's call it a kill count map. Every single cell in this new map is going to store the total number of enemies that would be destroyed if a bomb went off right there.
So, how do we actually build this amazing map? Well, it's a really neat four-step process. We're going to build it by sweeping across the original grid 4 times, once from each direction. All right, sweep number 1. We go through each row from left to right. As we go, we keep a running tally of any enemies we see. But as soon as we hit a wall, bam, the blast is blocked, so our enemy count resets to 0. We take that running tally and add it to our kill count map as we move along. Okay, now we just do the same thing but in reverse. We sweep each row from right to left. Again, we keep a running total resetting at walls. And here's the key part. We add these new counts to the values that are already in our kill count map. We're building on what we just did. You can probably guess what's next. We sweep each column, this time from top to bottom. Same logic. We accumulate the vertical enemy counts and add those to our map. A wall in the column, of course, resets that vertical count back to 0. And for the grand finale, our last sweep goes from the bottom all the way to the top. And just like that, our kill count map is complete. Look at that! Each number now represents the total enemies in its row and column, perfectly sectioned off by the walls. You know, what's really cool is how simple the code for this is. It's basically just a loop. For each cell, it just asks, is it a wall? If so, reset the count. Is it an enemy? If so, add 1 to the count. Then it just adds that running total to our map. That's it. It's so elegant. So with all that heavy lifting out of the way, finding the answer is now the super easy part. The map is built, the calculations are all done. All we have to do now is look at our completed kill count map. We just find the highest number that corresponds to an empty 0 spot on our original grid, and that's our perfect bombing location. And in our example from the very beginning, that highest value we can get in an empty spot is 3. That's our maximum possible damage. That's the answer. So what's the big idea here? What have we actually been doing this whole time? Well, this technique of breaking down a problem and storing the results so we don't have to do the work again, it has a name, and it's a huge deal in computer science. It's called dynamic programming. And really, at its core, it's all about being smart by being lazy. You solve each little piece of the puzzle just once, like how many enemies are to the left of a cell. And you save that answer so you never ever have to figure it out again. It's a fundamental idea used to solve all sorts of complex problems. So that leaves us with a final thought to chew on. This powerful idea of calculating something once and then reusing that result is absolutely everywhere. So where could you apply this principle of solve once,
use often to simplify